also. Additionally, every single math book out there has some type of conversion chart for you. In essence, keep in mind when we're converting things, we're not changing things whatsoever. We're just reporting them in different units. And there are some standard units that we deal with in the civil industry that we need to kind of know about. Okay, and I kind of just put little tick marks next to the ones that I think you really want to pay attention to here. Now, when we're talking about a mile, this is definitely our length measurement for transportation. That is the preferred measurement. You should know that 1 mile is equal to 5,280 feet. That is a constant conversion. Now, this will apply to you if you ever get into the transportation department, and also piping. I mean, certainly they're not the only ones. When we get into stationing. Now, remember I introduced stationing the other day, where if we start a project, and let's say I'm kind of drawing the center line of a road here that we are going to go ahead and work on. We would start the project right here, and we would use a station of 0 plus 0, 0. Now at that point, we would then divide this project along the center line into 100-foot increments. Okay? So we would come through and start laying out 100-foot increments on it. And this system works really well. But eventually, let's say we get a bunch of these, we get out here to station 75 plus 0, 0. Now, what we would then want to know is where's all our signage going? How are we calculating where this goes? Okay. We would come here. We know that every hash mark's 100 feet. Now, how do we get in between these? So if I wanted to know a point halfway in between here, this would be station 0 plus 50. Well, when you're driving down the highway, what kind of markers do you have along the highway that basically tell you where you're at? Mile markers. You ever wondered where those mile markers originate from? It's like borders of states is one.
From west to east. And from
west to east.
south to north. I'm not sure about that.
Okay. In essence, it also depends on where the road starts. You're thinking of an interstate road, a road that goes from state to state. We also have roads that are internal to states. We call them state highways. In essence, there, they'll generally start at a metropolis and then move north or east, one of the two in a positive function. Okay. So you're always wondering, you're on I-84 and you count those mile markers, you're going down, right? Because it starts at the Oregon border on I-84 and comes this way. Well, that's where they're getting all of this. Now, keep in mind, are those mile markers right? So when I get to a station like right here, and it is station 52 plus 80, I'm now 1 mile into the road, right? Because I'm at 5,280 feet. Is that road really 5,280 feet at that point? No, it's not. Because that road was developed off of a flat map. It did not take into account the rise and fall of the road. Which, if you know, if a road is going up, you're traveling the hypotenuse of a triangle. So these almost never will match up with what you're saying on your odometer, because it's measuring the tires turning, which is measuring all of that rise and fall, or the actual distance of the road. Now the thing is, we're going to lay this out, and we're going to stick these signs everywhere. We need to be able to convert miles to feet, because we are going to identify bridges, culverts, signages, junction boxes, everything on the foot system versus the mile system, but then the mile system is then used to go to the public. So some things to kind of think about where you're doing that. Now, we're going to pull those off of a flat map. Keep in mind, we'll call it out as that, and a surveyor will lay it out as that, but it's not actually that. Does that make sense? Because you're not taking into account the curvature of the earth and what's going on there. It's a flat XY measurement. But you need to know what that is because we convert it all the time. Has anybody heard of some of these terms like a furlong?
Horse racing.
Yeah, some of you always watch the Kentucky Derby or the
Just coming
Preakness or
up.
something, and they say, we're running 6 furlongs. And you wonder, what the heck does that mean? Well, convert it back to something you can visualize. Those of you that have gone through high school, not in our country, but you have a race that's kind of brutal called when I went through, a 220. Now it's called a 200. Well, that's 1 furlong. Okay? That's at 220 yards. That goes in, you take a furlong, come down here in the furlong, you're going to see that's a 220 yards, which is 200 meters. Okay? So now you can maybe visualize what these horse races are. The furlongs are kind of used in some layout measurements. It's mostly what I've seen used in the navigation of waters in today's world. They still use that unit of measure because they sound the depth with chains that are set up to that.
But where did it come from? I mean, what country? I mean, what's a...
You're going to see, if you look through this in great detail, you're going to see a lot of these related. Now, it all comes back to an old measurement system. That's a survey measurement called a chain. That's where it really started, back in the old days when they were laying out linear distances. And yeah, I'll get into that more in a minute when we get down to chains. But that's the original unit that we measured land with. So, know the mile, 5280. I think you already know this one. 1 inch, 2.54 centimeters. Okay, that's good. Okay. Now, let's go down to the chain one. Okay, I didn't put one on here, but you do need to kind of be aware that this unit of measure is out there. Because any drawing that's probably pre-1950s, the measurements will be laid out in feet, but when you went to the field, they were all laid out in chains. Now, when we did the Expo Center, we had a 300-foot tape, right? And we pulled measurements with it, and it had foot markings and inch markings on it. In the old days, we didn't have those tapes. We had a big roll of stuff, and I hate to say I'm old enough, I've seen these in action. They were still used in the late 70s, early 80s. It was a roll, and it was a solid steel chain. Now, that chain had so many links on it, and they used metal because it doesn't move as much as some of these other materials, and it was a constant distance. And then you would pull that chain out and hold it up, and you would measure and use a plumb bob to measure straight down to the earth so we could set off these XY distances. Now, the chain, when you come down here, it's exactly 66 feet. It had a link in it, 100 of them, so we could add those links up and know that, okay, I know this is 66 feet, so I have to be 0.66 feet for every link. So when you look at a chain, of course, it was just standard chain, right? That's not the best looking chain that's drawn. But when you would look at the distance from there to there, that was a link. And there was 100 of those in a standard surveying chain. Now, if you pull out some of our old civil drawings or go through we got a bunch of water rights stuff from the canal company hanging in the hanging folders, you're going to see all those measurements are in chains and links. Okay. And it was a way that we actually laid out property lines as we went through. So the big thing here is I want you to know that you do have a conversion factor from chains and links to inches and feet, so that if you're working off of an old drawing, you can convert it into our software working today. And we work in feet, mostly, in our software. Okay. Now, I don't know that I need you to memorize all of that. It's not going to come up that often, but you need to be aware it's out there.
Why didn't they make one of the links 5? I mean, why didn't they make it a number easy to read?
I wasn't around. I
I
didn't
know,
have
I
input
was like,
into the measuring
6.6,
system.
who came up, is that what just the standard size they made them?
Good.
That's stupid.
Yes, you know, I thought about that quite often.
It's like, why don't you make 5? I mean, that would have been a lot easier than 6.6.
It kind of goes back to what's a cubic, what's an inch? Whose thumb did they measure to get the inch mark? Because it's based off of a guy's thumb, right? I don't know. I didn't weigh in on those systems, I just have to use them. So I don't know that we really want to kind of look at the anatomy of it. All right, something we always put on here, acres We're always dealing with acres. Okay? So please know that 1 square mile, we call it a section. It is also 640 acres. You will see a lot of pieces of property broke into this. Okay? Because I think when we were developing the west, a homestead was 160 acres. So you can figure out the distance of it, but they had other land acts, like specifically the one I remember was one in Oklahoma, where they let people claim one section, okay, which was 640 acres. And it also was something was around here like that, because we see a lot of farms that originally started at 640 acres. Okay. Now all your roads, when you drive out in the country around here, they're 1 mile, right? So that block of your agricultural land in the middle is 640 acres generally. Right? So know your acre calculation for miles, also know it for feet. Okay? Because generally we're not dealing with these large pieces. We might be dealing with a small little cadastral map or a plot map that's one piece of property that might be around 1/4 acre up to 7 acres. We might be dealing with larger pieces that are many sections. Okay, but we will generally always list the acreage. When we draw the property boundaries, generally we just use the area command. It will give us the square area. Acre is an area term. And then divide it by 43560 and you get the acres. All right, any kind of questions on how to do a conversion? Well, let's find out. All right, let's just pick one out here. Some of these are fairly straightforward, but let's just see where everybody's at. Real standard calculation we do in civil is number 5. So let's all do number 5 and see what we get for an answer.
AC, acre?
AC is the abbreviation for acre. Feel free to use your conversion chart. I'm curious, Declan, did you give Gabe the answer? Gabe gave it to you.
Yes.
Okay, you might have had enough time to do this. First off, let me just put out a statement as a review. If I have 1 acre and I have right below it 43560 feet, okay, and I write that as a term, this is 1. That's equivalent to 1 because they are equal to each other. So therefore, when I times anything by 1, what is it? It's itself, right? Now, I wrote it that way, but can I also write it this way? 43560 feet divided by 1 acre. Is that also 1? Yes, it is. When you're doing conversions, understand when you have these equal units of measure, pay attention to your units, and you can in essence write them the inverse of each other, or upside down if you wish. Now, the units are going to tell you if you do this correct. Here, I have feet, I'm going to acres. If I'm going to get rid of the feet, don't I have to divide by feet? By the way, this is foot squared. I should write that correctly because acre is a square term, and you want to pay attention to the powers. So in essence, when I take this guy and I'm converting to acres, which one of those two expressions do I want to use? Do I want to use 1 acre over the feet, or do I want to use the acre underneath the feet?
1 acre over feet.
Yeah, so I'm going to times this by 1 acre over 43560 foot squared. Now, my feet squared cancel each other. And then I'm left with the unit I desire. Okay. So what do we get for an answer on this? Somebody got it? Gabe, what'd you get? 7 point,
10.46?
10.46, did I hear you correctly?
Yes.
And then AC, I'm getting deaf in my old age. AC, you gotta kind of yell. And just so we ought to record this, I'm gonna show my wife that not only am I ignoring her, I can't hear you folks either. So did you get 10.46? And make sure you're writing the units. Those units are important. Juan, did you good? Missy? Becca, did you get that?
Yeah.
Any questions on what we did here? Okay. I'd like you to finish filling out the rest of this sheet today and turn it in, please. I just want to make sure that you can get these. Mostly a review here, right? All right, enough on conversion factors. Next page is a list of maps that we will start with when you start design. So when you pull out a map, the first thing you're going to want to look for is what type of scale is it. Now on here for design, for the most part, we only use 2 types of maps for design. Okay? We use this one right here, okay, and we use this one. Okay. Those are the 2 that are generally used, depending on the scope of the project. Now, if I'm dealing with a project like a railroad or an interstate highway, something of that nature, I'm probably going to the Alaskan map. Because on this one, the scale is such that 1 inch is equal to 1 mile. So I can then use my 10 scale and I can just measure miles. This is good in the initial stages of design. I can say, hey, you know, I've got 862 miles that I have to deal with. Now eventually, this is too large a scale for us to do design on. We have to go to a smaller scale, and we generally go to this one right here, the 7.5 minute quad. Now, just so you, this one's called a 7.5 minute. You also have a 15 minute. Okay, that's also useful. You'll see this one out there. It's another useful one. Okay. The thing you want to keep in mind with these, where does that 7.5 minute or 15 minute come from? Anybody know? It's degrees. Remember, we have a degree, minute, second deal? So you have a planet that is set up, and it has a bunch of longitudinal lines, right? And it has a bunch of latitudinal lines, where we got the equator at flat. That goes like this. Each one of these are 1 degree apart. Okay, so what we're going to do is we're going to come in and we're going to grab one little tiny section that is equal to 7.5 degrees on the latitudinal side 7.5 degrees on the longitudinal side, and that is the land area that this map will cover. Okay, so it's based on the globe. That's where that number comes from. This one is really kind of the one of choice. Now, this was used pretty much up until about 10, 15 years ago. Okay. So the 7.5 minute quad. I put a bunch of maps around. I think Missy and Becca, you two didn't get one. You'll have to slide over to somebody else. But the map you have sitting on your desk is a 7.5 minute, and what we call is a quad, saying that it's 7.5 both ways. That's a real good design starting map. You can design quite accurately down to about 10 acres with that. So right down to about 10 acres. Many of you on those maps, you see some red lines in there? Red dotted lines, do you see those? Those are sections. Those are sections. Those of you that don't have a map, maybe slide over to somebody that does have one. You're dealing with the 7.5 minute quad. Okay, before I leave this, I'm going to leave this sheet right here. Here's just whenever you pull out a map and it's labeled at the bottom what type it is, like maybe an Alaskan or a 15 minute. There's your scale factor.
Where does it sit on?
It should have a scale section at the bottom. And let me just kind of pull some of this out on here. Okay. So you see a scale down here at the bottom? Okay. Now this scale goes with all maps.
They gotta have it.
Now you just draw, to put this scale together, you just draw it in model space. It's true size. That way whenever you scale your viewport, this will be scaled proportionally. So when you look at this one, which is 1 to 24,000, 7.5 minute quad. What is our DSF on this? Okay, let's kind of talk about the scale on it. Okay, so it's 1 to 24,000. What does it say on your sheet? It's 1 to 24,000, but 24,000 what? It's actually 1 inch to feet, correct? No, it's not going to say it. Really, it doesn't. It's just assumed that you know this. See it right here? What is our DSF of this drawing? There's going to be 2 DSFs, and this is a little bit kind of confusing when you first time see it. On a true map, if you're drafting this and you need to do your symbols, you need the DSF, right? Because your symbols want to be an 1/8 to 1/4 or something like that. Okay? Or text, all of that. Well, what's the first thing we do with DSF?
Get the units the same.
Get the units the same. So 1 inch is equal to, what's 24 times 12?
288.
288, and then we have 3 zeros. Is that correct? Pretty large reduction scale, isn't it? So far to date, we've dealt with architectural, which most of your biggest scales are 1/8. That's got a 96 reduction factor. But we're reducing this a lot. Now here I have inches to inches. There's your DSF right there, 288,000. When you put this in the computer, you are going to put it in where the computer is set up to decimal, and it is left on decimal to 2 decimal places. We'll go about this setup tomorrow morning. And we assume that our working parameters are decimal feet. So if I've got it set on decimal, and right now you type in 1 unit, you draw a line, 1 unit, it goes 1 inch, right? That's the way you assume it. What you're now going to do is you're going to draw a line 1 unit. CAD's going to think you're 1 inch. You're going to know that's 1 foot. Okay? You're going to just leave it alone and just work in decimal feet and put that in at 1 foot. You don't have to use the foot mark or anything. That's why it's easy. Now, what's your DSF of this in the computer? We consider this unitless. Okay. Your DSF is right there. Okay. Because we draw it unitless, we just know we're working in decimal feet. Now, to show you how this works, this map was actually drawn that way. The scale is just labeled like this. Take your architectural scale. It says 1 to 24,000. This thing's really 1 to 2,000. Take your 20 scale, put it on this graduated scale here, and measure from 0 to 1 mile. What do you get? No, you're engineering. Don't use an architectural scale on this.
This has the zero space time.
You're using your 20 side.
20.
Be trying to set this up so I can put it on the overhead here. Okay, so I did it upside down so I could show you on the overhead. So I got my 0 on the 1 mile side on the right. What am I hitting right here?
0.
Oh, 2.8, probably.
5.28. Okay, I just add a 0 to this. It is really, well, I actually add more than that because it's 5,280 feet. You know this is decimal feet. And add 1 0 to it.